Today I'm gonna teach you how to solve Rubik's Cube. You know, there are so many formulas out there, very complicated stuff, turn left, turn right, all of that. No, screw that. I found a very easy way to do that in 3 easy steps. Easy peasy lemon squeezy. Super easy to do. If you have Rubik's Cube at your home, definitely pause this video, bring it like to the screen of the computer. We're gonna solve it together. Okay, ready? Okay, step number 1. You need to solve any of the colors. Let's say red. Okay, let's say this red. Okay, and then second step, you need to learn filmmaking, because when you do filmmaking, you can do something like this. Now, oh, hold on. That's actually it. Sorry. Lecture number 23, let's go. Today we're talking about graphs again. First off, I want to tell you that that's almost the last lecture, the lecture before the last lecture. On Thursday, I think I'll also specify the list of the things I want you to study, I want you to watch, and you will kind of do the self-study thing. Because I received relatively positive feedback from the students. I think the key is to watch as many different YouTube tutorials on the same subject, on the same topic, because that gives you kind of like more people explaining the same thing. It just gets into your brain better, in my opinion. And of course read the book. That's the most conventional way of doing that. And people on YouTube, they definitely make mistakes, but like I've seen a lot of them like doing like crazy things. But the book never like all kind of is the reference, right? So there are, it's almost correct. It's always correct. That's the truth, right? So the truth is in the book and in the documentation. Anyway, also want to remind you that you guys are doing a very good job. 227 is almost over. After this class, if you pass this class, that means there is no doubt you can become a good computer scientist, software developer. Yeah, there will be, as far as I know, there will be no other class where there'll be other classes, especially by Professor Rao, which will be tough in terms of how much work you need to do, and in terms of it may not seem to be as useful as something else. But 190 to 26 to 27 will give you the most important fundamental knowledge of computer science and of how to code. And if you're thinking like what your future career like will be like, it will be this. You'll be like 2 to 26, 190 to 27, just doing that homeworks 8 hours a day. Okay, so it gives you a very good perspective of what to expect. So that's 1. And 2, it will not be classes when you're looking at something and you have like so abstract and it's very difficult to wrap your like mind around that. There'll be classes, especially with Professor Rao, which require a lot of work. Okay, but like it's very simple to understand work, versus this when the knowledge is so abstract and you like looking at the book for half an hour and you have no idea like what you just read. Okay, cool. Anyway, so this lecture I will be talking about the graphs. It will be something which you supposedly need to know already. It will be a short lecture. I'll be just talking about that one more time, because we almost actually we may be like a little bit ahead of the schedule. We're almost over with all the material. Okay, and the graphs is actually the last thing which we want to cover here in this class. Okay, let's get back to the slides. Okay, so I need to delete that. That's not true. Anyway, so what is a graph? Okay, the idea is like back in the day, some kind of mathematician, he was walking by the river, and of course, like he thought about maths. What else can you think about when you're just having a walk? Yeah, so he was walking like next to the river, and here's what he saw. He saw 4 islands, like 2 islands, C and D, okay, and like 2 shores, kind of A and B. And he saw 7 bridges. 1, 2, 3, 4, 5, 6, 7. Okay. And then he thought, okay, so is it possible to cross each bridge exactly once and to never repeat like the point? So the kind of, how to say that? So visit each bridge and visit each island exactly once. Okay. No, hold on. No. What was the question? Hold on, I forgot. Read it in the book. I forgot how it's formulated, the wording of that. hold on, 7 bridges graph problem. 7 bridges, yeah, historically notable problem in mathematics. It's negative resolution for the graph theory. Okay, yeah, yes. Walk through the city that would cross each of those bridges exactly once and only once. Yeah, okay, yeah. So can you visit each of the bridges exactly once? Okay, so for example, you go from like A to C like this, B to C like this, then from B to C like this, C to A like this, and then from A to D like this, from D to C like this, and then somehow go from B to D, but without crossing any bridges like more than once. Okay, yeah, that was the idea. Okay, yeah, so it doesn't really matter where you start, it doesn't really matter where you end. You just need to cross each bridge exactly once, and you need to cross each one, like all of them, and exactly once, not more than once, not less than once. So the answer to this particular problem is no, it's impossible, right? So like no matter like what you try to do here, you can try it for yourself. You'd have to cross like at least one bridge twice, okay? And kind of the solution to that is, so the reason why is that way, it's because like the D, okay, the point D has three connections. So if it had two, right, if it had like even number of connections, that would be possible. Since it has three connections, it's impossible. Okay, so that historically created a problem for graphs. Okay, that created the premises, and after that, mathematicians started like exploring the concept of graphs. Okay, so what is a graph? Formally, graph is a pair of two sets, not empty or non-empty. Okay, pair of two sets. A finite, non-empty, finite, that means it's not infinite. Okay, so like there is some number which you can count. Non-empty, which means it cannot be zero, it has to contain something. A finite, non-empty set V of items called vertices. In other words, those points, those dots are called vertices. And a set E of pairs of the items called edges. So E means edge, and those are those connections between vertices, between those dots. Okay. Graphs are useful in modeling and solving real-world problems. For example, the problem to find the least number of flights between two cities can be modeled using a graph, where the cities represent vertices and the flights would be edges. For example, take a look at this. Seattle, Chicago, Boston. Am I recording, by the way? Yeah, I am. New York, Denver, Kansas City, Atlanta, Dallas, all of that, right? So where's Atlanta, right? And we're somewhere here. Yeah, so those dots would be vertices. Like when we're talking about trees, right? We're talking about nodes. Okay, so in graphs, those nodes are called vertices. Yeah, so here we have vertices, all of those dots, then lines between them, so-called edges, right? That's kind of the flight route between the cities. That's what it represents. Okay. Now you need to know definitions. It's very important to know definitions to sound smart, to sound competent, to sound intelligent, and to understand like the formal literature. Okay, because that's how like that literature speaks. Literature speaks in terms of the definitions. It's very important to know them. Yeah, ideally you need to also like be able to speak formally and have formal definition for each one of the terms. Okay, but at least you need to know what's behind them, what they mean. Okay, some definitions. If these pairs of vertices are unordered, right? It as a pair of vertices UV, which means that when the edge goes from vertex from the dot U to the dot V, is the same as when it goes from V to U, we say that the vertices U and V are adjacent to each other and they are connected by the undirected edge. So here's the idea. In a graph, there are so-called directed graphs and there are so-called undirected graphs. Undirected graphs is something which you see right here. Okay, the idea is that there are no particular directions those lines, those edges go to. For example, you can go from Seattle to Chicago, right? So you can go that way, but you can also go from Chicago to Seattle. That's also okay, right? Sometimes some graphs only have one direction edges, okay? Unidirectional edges. For example, let's say for some reason it was only possible to go from LA to Kansas, but not from Kansas to LA. In this case, from LA to Kansas, we would just draw it like this way. That's how we draw that, which means that that's the only direction possible. It's impossible to go the other direction. Okay. Yeah, hope it makes sense. Anyway, if I have two cities, if I have two vertices and they're connected by an edge which doesn't have any direction, we call those two vertices are to be adjacent to each other, which means they're neighbors. Okay, technical term is adjacent. Okay, and that edge between like this guy and this guy is called to be undirected. So there is no particular direction, which means it can go both directions. You can go from San Fran to Seattle, from Seattle to San Fran. Hope it makes sense. We can call vertices U and V endpoints of the edge. So for example, let's say I have this, okay, and let's say I have two, that's the edge, those are the two vertices, okay, and that's, let's call this guy U, this guy V, okay. We'll call vertices U and V endpoints of the edge. So this is, okay, this is the edge called UV, and let's say it is directed. Damn. UV. Okay. Yeah. Hold on, one more time. Sorry about that. I'm trying to get used to this this tool. It looks very useful, but it causes some issues. U, comma, V, boom. Yes, perfect. Okay, so that's an edge called UV. It goes from U to V, and it happens to be unidirectional, so directed edge. So there is a direction which this edge has. Okay. Okay. We call the vertices U and V endpoints, right? So that's the endpoint, and say that U and V are incident to this edge. So kind of you have an edge, you have this edge, you have this line, and this line connects two dots. Those dots are incident to this edge. We'll also say that the edge UV is incident to its endpoints U and V. Okay, a graph G is called undirected if every edge in this graph is undirected. So this particular edge is directed because it has direction, right? This graph is called undirected because all the edges, all those lines, do not have any direction. Hope it makes sense. Moving on. If a pair of vertices UV is not the same as the pair of VU, right? Which means you can go from U to V, but you cannot go from V to U, okay? That will be directed. Then we say that the edge UV is directed from the vertex U, which is called the edge's tail, right? So again, so U would be called the tail, okay, like the ponytail or tail of any other animal, and vertex V is called edge's head. Okay, we also say that the edge UV leaves, so it goes from U to V, right? It leaves U and it enters V. All of those words in bold, the terms which you need to know. A graph whose every edge is directed is called directed. Okay, directed graphs are also called digraphs, which is short for directed graphs. Okay, hope it makes sense. That's actually what we will start also with in 3.18 class, which you'll probably take in spring next year. Yeah. Anyway, some definitions also. So this graph is called directed. You see, I have like 1, 2, 3, 4, 5 vertices, and I have edges in between them, and each one of them is directed. That's why it's called directed graph or digraph. This guy is called complete graph. Okay, so what does it mean, complete graph? Complete graph, that means that there is an edge or there is a connection between any two dots, between any two vertices. For example, take any pair of vertices, any pair of dots, like in this graph. For example, I don't know, CA, CD, BE. There is always an edge. There is always something between them. No matter how hard you try to find two vertices which are not connected, you will not be able to. Okay, and that's called a complete graph, when there is connection between between every two nodes, every two vertices. Subgraph of the graph B. Okay, so I have this complete graph, and this is called a subgraph. Subgraph, that means you take this complete graph, or you take any graph, and you just delete a few edges, a few vertices, right? Kind of a subset. So just take a set, remove a couple of things, and there will be subset. Take a graph, remove a couple of things, there will be subgraph. The degree of the vertex is the number of edges it's incident to. For example, degree of this vertex is 2. Why? Because it's incident to one edge, second edge. The degree of this vertex will be 1, 2, 3, 4. 4. Okay, that's the degree. Two vertices are called neighbors. Okay, that makes sense. Okay, if they're adjacent. Okay, so for example, C and E would be neighbors. If B and E will be neighbors because they're connected by an edge. B and C over here will not be neighbors anymore because why? There is no edge between B and C. Okay. Next, loop. Loop is an edge that links a vertex to itself. It's not represented here, but let's say, let me try to draw that. If there was an edge going like from B and coming out of B and going back to B, leaving B and going back to B, that would be called a loop, right? Yeah, that's a loop. Moving on, that's called a loop. Now, if two vertices are connected by two or more edges, these edges are called parallel edges. Parallel edges. For example, let's say there is an edge between B and A, and let's say I decide to draw another one. And it will go like this. Okay, so I kind of have two edges, and it's possible, it's totally fine to have that. I'm gonna have two edges between A and B. Okay, and that will be called so those two edges will be parallel. Okay, because they're parallel. Yeah. Moving on. A simple graph is one that does not have any loops or parallel edges. So a graph is called simple. For example, I don't know, this graph is simple, this graph is simple, this graph is simple because it does not contain any loops or parallel edges. In a complete graph, in a complete graph, every two pairs of vertices are connected. Okay, so that's called a complete graph. Every two pairs of vertices are connected. Moving on. A graph is connected if there exists a path between any two vertices in the graph. Okay, so a graph is called connected when you can go from any vertex to any other vertex through some edges where there exists a path. Like think about the path in binary tree or just a tree, right? So path would be like sequence of edges. So here's the same thing. For example, what is the path between, let's say, this guy over here and this guy over here? So from D to A, from A to C. Okay, so there exists a path how to go from D to C, basically through A, right? For example, there exists a path between C, let's say, and A. Okay, so how can you go from C to A? You can go like this, from C to A directly.
You can go through B, C, B, B, A. You can go C, E, E, A. You can go C, E, E, B, B, D, D, A. That's also possible. Those are all valid paths. So path is a sequence of edges which you can take in order to go from one vertex to some other vertex. Moving on. What else? A subgraph of a graph G is a graph whose vertex set is a subset of that G and whose edge set is a subset of that G. So that's a formal definition for G described. A cycle is a closed path that starts from a vertex and ends at the same vertex. Okay, so there is a difference between cycle and a loop. Cycle and a loop. So loop is something which I already described. A loop would be, for example, if I go from C, so that would be a loop. An edge comes out of C, comes back to C. A cycle would be a sequence of edges which come back to the same vertex. For example, a cycle would be this: CD, DA, and AC. Okay, so it's like 1, 2, 3, 3 edges. Okay, which create a cycle. So that's the loop, and that's a cycle. So loop is kind of a cycle which has only one edge. Cool. Yeah. So moving on. How to implement a graph of cities. Okay. So in Java, and that's what you're going to learn next. There are a couple of ways to create graphs and to implement them. There is some API, and of course, like remember how we're talking about the linked lists, stacks, queues, right? There is an idea of a linked list, an idea of a queue, which is the concept, and there is API, which there is a specific implementation of queues, right? Same thing for the graphs. There is an idea of a graph, and there are some classes in Java which are already built in, which represent graph. You can either build a graph from your from scratch on your own, and that's of course much more complicated, but you will know exactly how it works. In general, that's not recommended because most likely you're gonna have some mistakes there. And there are classes for graphs which are already there in Java. You just need to learn how to use them. But let's say if we're creating the graph by ourselves, how to implement a graph of cities, right? So let's say we want to do exactly this stuff over here by ourselves. We would create vertices, an array of vertices. So we'll just call it string vertices and put all the cities there. And then we would create edges. How do you create an edge? And that's a problem, right? So that's there are two ways of doing that. The two most popular ways of doing that. One of them is called adjacency matrix. Okay, basically, let's say over here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 cities. Adjacency matrix means that you're going to create a 12 by 12 matrix. So they're going to be like 12 rows, 12 columns. Okay, and then over here you would put either 1 or 0. If you put a 1 there, that means there is a connection, there is an edge between the element at the corresponding row and the corresponding column. For example, okay, so we see 1 here, okay? So 1 means what? 1 is San Fran, okay? So what are the coordinates of this 1? It's 0th row, first column, which means there is a connection between Seattle, which is the 0, and San Fran, which is at the first position. Okay, so Seattle and San Fran. Okay, yeah, we see that there is an edge, there is a connection, right? What does 0 mean? 0 means there is no connection between 0th row and second column, right? So 0th element and second element, there is no connection. 0 element Seattle, second element LA, there is no connection between Seattle and LA. Is that correct? That's Seattle, that's LA, there is no direct connection. Okay, so basically go through this entire like 12 by 12 matrix. You put either 0 or 1 depending on if you have an edge there, if you have like a connection. Okay, so that's one way of doing that, and there is another way is to use is that adjacency list, right? Would that be adjacency list? Yeah, so adjacency list. Okay. Yeah, so here's another way of creating the edges, okay? So basically specifying, yeah, that'll be called the so-called adjacency list. So you basically specifying each edge, like all the edges which exist there, right? Not inside of like two-dimensional matrix. You basically like put in the pairs of those edges. 0, 1, what does that mean? That means there is a connection between 0 and 1. 0, 3, what does that mean? That means there is a connection between 0 and 3. 0, 5, what does that mean? That means there is a connection between 0 and 5. The 0th element of the series and the 5th element of the series. 3, 0, what does that mean? That means there is a connection between 3rd and the 0th elements. Keep in mind that you see 0, 3 here, 3, 0 here. That means that you can go from 0 to 3, and from 3 to 0, which means it is undirected graph, right? So there is no, like you can go both direction, from 3 to 0 and from 0 back to 3. Yep. What else? Yeah, so if you were creating the graph by yourself, here's what you have to do. You need to create a class called edge, int u, int v, right? You need to create, well, first off, you need to create like this matrix, or this matrix, up to you. Then you would create a class for edges, uv, edge uv, okay, and then like equals, okay. So the returns u is equal to edge of u that u, of o that u, and v of that v, okay. So if this edge is equal to the edge which is being passed in. Now, yeah, and then you can create a list, okay, a list of edges, and you just add there like all the edges there, okay. Adjacency list. The other way to represent a graph is by using adjacency list. An adjacency list is an array A of separate lists. Each element of that array, of the array A, is a list, okay, which contains all the vertices that are adjacent to the vertex I. Sorry, AY. AI, sorry, yeah, so AI meant to be that way. Okay, for a weighted graph, the weight or cost of the edge is stored along the vertex in that list using pairs. In an undirected graph, if the vertex j in the list is connected to the I, there will be 1. Okay, yeah, hope it makes sense. You guys already like read about that. Okay, so now, yeah, again, adjacency list. The space complexity of the adjacency list. Yeah, so if we compare, what's more efficient, time efficient? Is it better to use adjacency matrix or adjacency list? It's better to use adjacency list. It's better in general, and that's what's being described here. Okay, so let's say you have a graph, right? So adjacency list would look like this. A1, what is it connected to? It's connected to 2. It's connected to 4. So A1 is connected to 2, connected to 4. A2, what is that connected to? 1 and 3. So there is a list of 2 elements, 1, 3. So A2 is connected to 1, connected to 3. A3 is connected to 2 and 4. A4 is connected to 1 and 3. Okay. Now, if we're talking about directed graph, okay, so 1 is connected to 2, but technically it's not connected to 3 because there is an edge between 1 and 3, yes, but it goes only one direction, from 3 to 1. Okay, so that's why over here, when we create an adjacency list, we go only from 1 to 2, but not from, we'll go from 3 to 1, right, but not from 1 to 3. That's why it changes that drastically. Okay, and last thing which is I mentioned here is that there is also something which is called a weighted graph. Okay, so weighted graph is something like this. For example, San Fran, Los Angeles, right? So let's take a look at this edge. Okay, it's pretty short, and this guy over here. So what's the distance between the San Fran and Seattle? It's much longer, right? In an unweighted graph, each edge has either exists or doesn't exist. That's it. There is no other information about that. But in a weighted graph, each edge also has a weight. So it's not only about does that edge exist, does the edge between LA and Seattle exist or not, right? So in this case it doesn't. But it's also about if it does exist, like how big is that? So there is kind of one more additional piece of information which you need to know. In this case, for example, there can be distance.
Okay, so there is a difference between going from San Fran to LA and going from San Fran to Seattle, right? And the difference is that it's huge. It's like how many hours it would take you. So that's why in situations like this graph would also be not only undirected, but it will also be weighted, which means each one of those edges would have weight, which will be the distance. Let's say 787 miles, and here let's say 100 miles. But other than that, that's pretty much the same thing. Yeah, cool. Hope it makes sense. I'll see you guys later in the next lecture, or maybe some other videos. Hope you have a nice day, and please stay safe. I hope your coronavirus is not impacting you that much. I'll see you guys later. Bye bye.